let's look at part A of guided practice 2. Now, just as a reminder, just as we talked about the product property of radicals, and I'm just going to put it up here on the right, the square root of AB equals the square root of A times the square root of B. The reason that we can do what we're doing, just as a refresher, is because the reverse is true. The square root of A times the square root of B equals the square root of AB under the radical. All right, that was the product property of radicals. All right, we're going to use that property over here just as we did before. And our first step is to multiply everything together. And we get 2x to the fourth, the square root of 2x to the fourth. Now, this is not simplified yet. So now that I've got this product in that radical, I'm going to now simplify that. So the square root of 2x to the fourth can be separated as square root of 2 times the square root of x to the fourth. Well, you know x to the fourth is x squared times x squared. So x to the fourth is a perfect square, right, of x squared squared. And so we can take out one of these x squareds and multiply it by the square root of 2. And because of convention, we always put the x squared in front. So the answer is going to be x squared square root of 2. We're going to rewrite it just so it looks right. Okay, that was guided practice 2, part A. We're not going to do part B quite yet because this was the product property of radicals. I'm going to sneak those words up here because I don't have a lot of space. The product property of radicals. But there's also a quotient property of radicals. And that property says that the square root of A divided by B equals the square root of A divided by the square root of B. And it is understood that the reverse is also true, that the square root of A over the square root of B equals the square root of A over B. Okay, and this is important, and we're going to use it quite a bit. So let's just do a couple of examples. Let's take the square root of 16 over 25, and the whole thing is in that square root. Well, because of the quotient property of radicals, I can divide this as square root of 16 over the square root of 25, and I know the square root of 16 is 4, and the square root of 25 is 5. So this whole thing gives me 4/5. So if you look at example 3 in the book, and you look at part A, they are going to ask you to look at how can I simplify the square root of 13 over 100. Well, using my quotient property of radicals, square root of 13 over 100 equals the square root of 13 over the square root of 100. Now, the square root of 13 can't be simplified any further than it is, so I'm just going to leave it as is. But the square root of 100 can be simplified to 10. And when I have the square root of 13 over 10, I've simplified it as much as it can be, and I can leave the answer this way, as is. Let's look at part B. And you'll notice part A always has numbers, and part B, they throw in a variable, and that's what's going to happen here. So the square root of 7 over x squared. Just as I did above, I'm going to separate each of these. I'm going to do the square root of the numerator, which is 7, and the square root of the denominator, which is x squared. My numerator stays because I can't simplify the square root of 7 any further, but my denominator can be simplified because the square root of x squared is just x. So my answer is just going to be the square root of 7 over x. So now that I've done that, we can do guided practice 2, part B. So take a second and do that. I want you to simplify the square root of 1 over y squared. Okay, so we're going to separate this as the square root of 1 over the square root of y squared. Square root of 1 is 1, and the square root of y squared is y. And so our answer is going to be 1 over y. Okay, so we have gone through most of this lesson. I have only one small part to teach you, and that part is the part that I try to tell you at the beginning is one of the reasons this is such a powerful technique. So this is called rationalizing the denominator, and I will do more of this tomorrow, but I need to introduce it to you as you'll probably see it in your homework. It's called rationalize the denominator. Again, a very fancy word to describe something simple. Very, very simple. And really what it means is get rid of the square root in the denominator. It's a way to get rid of the square root in the denominator of a fraction. That's all that it is. So if I have 5 divided by the square root of 7, you'll remember the phrase, there can never be radicals in the basement, right? You can never ever leave a square root on the bottom of a fraction. It's just not allowed in math. So what do? We've got to get rid of it. Well, the way to get rid of a square root in the denominator is to multiply it by the same number, because if you multiply square root of 7 by the square root of 7, you have the square root of 7 squared, right? Which is 49, which will end up giving you 7 on the bottom. So you've now lost your radical on the bottom. The only way you're allowed to do that is if you multiply square root of 7 over square root of 7 on top, so that you really are just multiplying by 1. And so you will end up with 5 times the square root of 7 on top, and that's going to carry all the way here. So 5 divided by the square root of 7 will give you 5 square root of 7 over 7 when you have rationalized the denominator, which means you multiplied by the square root of 7 over the square root of 7 so that you could get rid of this radical in the basement or the radical in the denominator. So let's look at another example. What if I have 7 over the square root of 6? Well, I need to get rid of that square root of 6 in the denominator, right? So I'm going to multiply by the square root of 6 over the square root of 6. And this is going to give me 7 square root of 6 on top and the square root of 36 on the bottom. But of course the square root of 36 is 6, so I end up with 7 square root of 6 over 6. One last example of rationalizing the denominator, and then you're going to be done for the day. This is going to be a denominator that includes a variable, because we always need to learn how to work with variables, because this is algebra. So square root of 2 over the square root of 3b. Well, even though this is a different looking square root on the bottom, we treat it the exact same way. If I want to get rid of square root of 3b, I have to multiply by the square root of 3b. It's that simple. So square root of 3b over square root of 3b. And I end up with square root of 6b on top and square root of 9b squared on the bottom, which simplifies to simply 3b and square root of 6b on top. And so the square root of 2 over the square root of 3b ends up giving me square root of 6b over 3b. That's it. So that's all that you need for your homework. Good luck, and I'll see you tomorrow to finish the chapter.